Welcome to week 5. We will be solving systems of equations this week. Remember, there are 3 ways of solving systems of equations. We have solving by graphing, solving by substitution, and solving by elimination. And I'm going to illustrate all 3 of these for you today. And then I'll also be posting some other links for extra practice if you need it. Okay, so let's start with graphing first. If we're going to solve by graphing, what we're trying to find is where these 2 lines cross. So, of course, we've got to actually graph the lines. Now, you'll notice neither one of these are in slope-intercept form like we graphed from last week. So I need to get both of these in slope-intercept form. And what we learned last week was slope-intercept form looks like this, y equals mx plus b, where we have solved for y. So what I've got to do is in both of these equations, I've got to get y all by itself, move everything else away. So we'll start with this first equation here. 5x plus 2y equals 4. Remember last week we learned we want to move the x term first. This is a positive 5x, so we're going to subtract it from both sides. So we're left with 2y equals, now we want it in this order, so I put the negative 5x first and then the plus 4. And then our second step is to divide away whatever's in front of y. So everything is divided by that. So those cancel out and leave us with y, which is what we were trying to do. We have a fraction here and it cannot be reduced, so we'll just leave it like it is. This is our slope, negative 5 over 2, x. Remember, the slope is just the number in front of x. So the slope is negative 5 over 2, and it's being multiplied times x. Plus 4 over 2 is just 2. There's our first line. So let's go ahead and graph that line. Remember, to graph it, we start with a y-intercept. Remember, this is the y-axis going up and down. So this is where it crosses the y-axis. So it's going to cross at positive 2. The slope is negative 5 over 2. Remember, slope is rise over run. So negative 5, I'm going to go down 1, 2, 3, 4, 5, and then over 2. Let's go ahead and do one more. 1, 2, 3, 4, 5, and over 2. If you wanted to go the other way, we could go up 5, 1, 2, 3, 4, 5, but we would need to go back 2 just to go the opposite direction. And then we can draw a line here. Okay, so then our next line, this one right here, I'll come down. We have 3x plus 6y equals negative 12. So again, I want to solve for y, so we're moving the x term first. So it's a positive 3x, so we're going to subtract 3x from both sides. So we're left with 6y on the left. Again, we're going to put it in this order of mx plus b, so the negative 3x and then the minus 12. And then we got to divide away what's in front of y. So everything gets divided by 6. Okay, so that cancels out, leaves us with y. That's what we wanted. Now, can we reduce this? Well, it's going to be a fraction because my number on top is smaller. Anytime your numerator is smaller, we know we got a fraction. But 3 will go into both of these. 3 will go into negative 3, negative 1 times, and 3 will go into 6 2 times. So we're going to reduce that. And negative 12 divided by 6, that's going to be negative 2. So now we solved this one for y, and we can graph it. So this time, this line is going to start at negative 2. So right here, that's my starting point. And then my slope is negative 1 over 2. So down 1 over 2. Down 1 over 2. Look at that. We just found where they crossed. Down 1 over 2. Or remember, you could go up 1 and back 2. And then when we draw the line, we see where they cross is right here. That's our solution. So the solution to this equation is, and you can write it as a point, this is x is 2 and y is negative 3. And that's solving by graphing. So to solve by graphing, get both equations, solve for y, graph them in slope-intercept form, start at the y-intercept, use the slope, and wherever they cross, that is the solution. Okay, let's try solving by substitution now. Now, substitution, remember with substitution, you are substituting something in the place of something else. With substitution equations, hopefully one of the equations is already solved for a variable or could be solved for a variable very easily. In this case, notice how one of our equations, we already have a variable all by itself. In the first equation, it says x is equal to 2y minus 3. That means they have the same value. That means that instead of writing x, I can write 2y minus 3, and they mean the same thing. They have the same value. So instead of x, in the second equation, I am going to substitute in 2y minus 3. Watch this. So I'm going to rewrite this equation right here. 2, but instead of x, I'll do parentheses, and I'm substituting in 2y minus 3 in place of x. Notice this is still just 2x, that's why I substitute in place of x, minus 3y equals negative 5. How this is helpful is now I only have one variable. All I have is y's, and so I can solve and figure out what y equals. So let's go ahead and do that. So for solving an equation, remember if there is any distributing, that's going to happen first. So 2 has got to be multiplied by 2y. 2 has got to be multiplied by negative 3. Then we have the negative 3y equals negative 5. Now we have like terms here we need to combine. 4y and negative 3y, that's going to be just positive 1y, or you could write just y, minus 6 equals negative 5. Now to get y by itself, I need to move the constant. That's a negative 6, so we're going to add 6 to both sides. So y equals 1. Now to figure out what x equals, I'm going to take this, now that I know what y equals, and plug it back in. So x equals 2 times, we now know y is 1, minus 3. 2 times 1 is 2. 2 minus 3 is negative 1. So our solution, just like we did with substitution, we're going to write it as a point. Remember, anytime you write a point, it's x and then y. So x was negative 1, y is 1. There's your solution. Now, what if one of the equations does not have a variable by itself, like here? So they're still asking us to solve by substitution, but neither one has a variable by itself. Notice in the second one, though, see that y right there? Wouldn't that be really easy to get by itself? Let's do that. If we want to get y by itself here, I just need to get rid of that 7x. So to get rid of it, I do the opposite to move it to the other side. So we have y equals negative 7x minus 8. Now we have a variable by itself, and that's what it equals. Okay, so I just transformed this second equation. I just took the second equation and I transformed it so it was in terms of just one variable. I can now, instead of y in the other equation, substitute in. So 2x plus 5, but instead of y, we're going to write negative 7x minus 8 equals negative 7. Got a little distributing that needs to happen here. So the 2x stays out here. Then 5 times negative 7x is negative 35x. 5 times negative 8 is negative 40 equals negative 7. Got some like terms to combine. So we have a 2x and a negative 35x. They're on the same side. So 2x minus 35x, that's going to be negative 33x minus 40 equals negative 7. We can add 40 to both sides. Ready to start getting that x by itself. So we have negative 33x equals 33. Then divide both sides by negative 33. Got x by itself now. And 33 divided by negative 33 is negative 1. Again, to find y, I'm just going to plug this back in. I'm going to plug it in this one because that seems easiest. Y equals negative 7. We now know x is negative 1 minus 8. Oof, lots of negatives. Let's be careful. So we have a negative 7 times a negative 1. That makes a positive 7 minus 8. And 7 minus 8 is negative 1. So in this case, x is negative 1, as is y. And that is your solution. Okay, so the last way of solving these systems of equations is by elimination. With elimination, you are trying to eliminate a variable. And so what I'm trying to do is I'm going to combine these two together. I'm going to add them together and make one of the variables go away. So I need the coefficients in front of one of the variables to be the same number but opposite signs. Well, right now I have 1 in front of the x and 2 in front of the x. Those are not going to cancel out. In front of the y, I have a positive 5 and a negative 7. Okay, so none of these are set up yet. So what I can do in this case is I'm going to multiply by something that will cause them to be the same number but opposite signs. Let's get rid of the x's. Let's do the x's. So in order for these to go away, I would need one to be a positive number and the other to be a negative number, and I need them to be the same. So since this is already 2, I can very easily turn this into a negative 2 by multiplying the whole entire equation by negative 2. So negative 2 times 1x is negative 2x. Negative 2 times 5y is minus 10y. Negative 2 times 20 is negative 40. And then I'm just going to rewrite the second equation here. So you can multiply one or both equations by any number as long as you multiply every single thing inside every single term inside the equation by the same number. Now notice what happens if I add these two together. Negative 2x and positive 2x are gone. That's what I wanted to happen. Negative 10y and negative 7y, that's negative 17y, equals negative 40 and negative 45, that's going to be negative 85. And now, to get y by itself, I'm going to divide both sides by negative 17. So negative 17 divided by 17, that just leaves us with y, which is what we wanted. Negative 85 divided by negative 17 is 5. And now to solve for the other variable, I can plug it into either one of my original equations. I'll just go with the first one. So x plus 5, well, now we know y is 5, equals 20. So 5 times 5 is 25. And to solve for x, I need to subtract 25 from both sides. So x equals negative 5. So my solution here, x was negative 5. And y was 5. All right, let's try one more. Solving by elimination. Okay, so on this one, if you'll notice, if I'm going to eliminate one of the variables, I have a coefficient of 4 and 5 in front of the x's, and a coefficient of 3 and 4 in front of the y's. It really does not matter which one you decide to get rid of. You're going to end up with the same answer at the end. If you did this and got rid of the x's, and I did it and got rid of the y's first, we would still end up with overall the same answer. Let's get rid of the y's this time since we got rid of the x's last time. Okay, so what's the first number that both 4 and 3 will go into? Well, that's going to be 12. So what do I need to multiply 3 by? Well, I'll need to multiply it by 4, and I'll need to multiply 4 by 3, but one of them needs to be negative. So doesn't matter which one. We'll multiply the top by negative 4 and the bottom by positive 3. Okay, so let's see what happens. I'm just drawing an arrow here. All right, so negative 4 times positive 4x is negative 16x. Negative 4 times 3y is negative 12y. Negative 4 times negative 1, that's going to be equal to a positive 4. Okay, let me draw an arrow here. 3 is going to be multiplied by everything, so 5x times 3 is 15x. 4y times 3 is positive 12y. We worked. We're good here. And then 3 times 1 is positive 3. So remember, you want it set up so that when you add these two equations together, one of them cancels out. Where they're the same number, opposite sign, we're good. So negative 16x and 15x is negative 1x. That's gone. 4 plus 3 is 7. Divide both sides by negative 1, and we have what x equals. And then just plug it back in. Let's plug it back in the first one. So 4x, we know x is negative 7, plus 3y equals negative 1. See, this is just 4x. We just know x is negative 7, plus 3y equals negative 1. So negative 28 plus 3y equals negative 1. Add 28 to both sides. 3y equals 27. Divide both sides by 3. And y is 9. So our solution, -7, 9. All right, y'all. Be careful.